So this is a very interesting problem here. So what this question basically asks is that what raised to power something is something raised to power what? Now you can intuitively say that if x equals to 2 and y equals to 2, then it's the same thing as y raised to power x. But you can see that our condition tells x cannot be equal to y, and we can also say that though one intuitive solution to this, and I think it's very trivial, is 2 raised to power 4 is equal to 4 raised to power 2. So I think this is a very nice solution to it, and there exists more solutions. As you can see, it is said that, like the question already states, that x and y belong to real numbers, but we can say there are more solutions because we can plot the surface graph of this and check. Like you can see there are many more intersections than just 4 comma 2 and 2 comma 4. So it is a nice problem to begin with. So what we can basically do here is we can consider y. We can consider y to be some value. We can consider it to be some multiple of x. And remember, t here is a real number, cause if t is complex, then since x is real, y will become complex. But that's not in our solution. We need x and y to be real, so t will have to be a real number. Now what we can do is we can substitute this back in the equation, and I'll just use a different color. uh, we can write this as x to the power tx is equal to tx to the power x. Now what we can do here is uh, we can we can raise each side to the power 1 over x. In that case, a lot will be simplified. Also, we can notice we can raise it to 1 over x power, cos since x is not equal to y is not equal to 0, we cannot just put 0 to the power 0 and 0, because we can't take we're just neglecting the zeros. So raising both sides to the power 1 over x, it will become tx to the power x to the power 1 over x. So the x and x will cancel off, and we'll remain with x to the power t is equal to t to the power x. Now what we're gonna do, we are just gonna raise each side. We're just gonna divide each side with x again. Since x is not equal to 0, we can actually do that, and then we'll remain with x to the power t minus 1 is t. So now what we're gonna do is we're gonna raise each side with 1 by t minus 1. So that will become something like this. And so voila, we'll have x is equal to t to the 1 by t minus 1. I think we got our solution for x, and now what we'll do is we'll just substitute this x back into the equation uh, for y. So we'll get y equals to t into t to the power 1 by t minus 1, and then if you simplify it, we'll get y as t to the power t by t minus 1. So that's the solution for y. And now any real number you take, uh, let's say t is equal to 3, then x will become t to the power 1 by t minus 1. Then x will become uh, 3 to the power 1 by 2. So that's just square root of 3. And since t is 3, y will become 3 to the power 3 by 2. So that's just the square root of 3 cube, which is 3 cube. which is the square root of 27. So what this essentially means is root over 3 raised to the power root over 27 is equal to root over 27 to the power root over 3. I think that's a very nice solution, and then you can generate infinite number of points using these two general solutions. Thank you.